Hello, YouTube. This is Mr. Bakari, and today we're going to talk about the discriminant and the power of the discriminant. And what we mean by the power of is this value, which we call the discriminant, can determine the nature of roots without having to solve the actual quadratic equation. Okay? So let's get started. All right, up here in the top right-hand corner, we've got the quadratic formula. And the value under the radical is what we call the discriminant. And what that tells us is the nature of the roots. Okay? So we're looking at three scenarios. When we simplify that value, is it less than the zero? Is it equal to zero? Or is it greater than zero? So first, let's look over here on the right. If the discriminant is less than zero, what that means is we've got two complex roots, or what we would call imaginary. Okay? Two complex roots or imaginary. And what that means, if you look at the graph, is that our parabola does not cross the x-axis. So if it does not cross the x-axis, it does not have any real roots. Okay? The second scenario is if we simplify the discriminant and it equals zero. What this tells us is that we have one real root, one real repeated root. Okay? And as you can see, it's like a bounce, right? The vertex sits on the x-axis, the graph bounces and goes the same direction as where it came from. Okay? One real root if our discriminant equals zero. Okay? And then the third is the discriminant is greater than zero. Greater than zero. So if it's greater than zero, what this means is we have two real roots. And as you can see on the graph, it passes through twice, two real roots. Now, this can be categorized into two different tiers here. We've got two real roots that is a perfect square. So if we get a perfect square under the radical, then that is two real roots, but more specifically, those are what we call rational roots. Two rational roots. And then the other scenario is we simplify and we get a number that is not a perfect square under the radical. So our discriminant is, say, 17. This is going to give us two real roots, but two real irrational roots, okay? Irrational roots. All right? And that's what we mean by finding the determining the nature of the roots. So we can do this without having to go through and solve the entire equation. So this is a common question that's asked in an algebra class. What is the nature of the roots? And this is how you do it. So now we're going to look at a couple of examples. Okay? So first thing is we need to remember what standard form looks like, okay? ax squared plus bx plus c equals y. Now, it needs to be in descending order of power in order to be in um, standard form. So if you look, all three of these are already in standard form. And so now we can identify A, B, and C. Okay. So we're going to look at the discriminant, which is again B squared minus 4AC. So if I look at B squared minus 4AC on the first one, B is negative 4 minus 4, A is 1, and C is 4. Okay? So I'm going to do my square first, which is 16, and then I'm going to multiply. 4 times 1 is 4. 4 times negative 4 is negative 16. So 16 minus 16 equals 0. So my discriminant is 0. This means I have one real root. Okay, let's look at the second one. We're in standard form. B is -6. So I'm going to square that. -4. A is 1. C is 5. Go ahead and square -6. And then we're going to multiply 5 times 1, which is 5, and 5 times -4, which is -20. 36 minus 20 equals 16. 16 is positive, so that means we have two real roots. Two real roots. Now, is it rational or irrational? Are my two roots rational or irrational? Well, this is a perfect square, right? So since it's a perfect square, we have two real rational roots. Okay? And if we look at the last one, standard form, b -6 squared minus 4, a is 1, c is 4. Again, -6 squared is 36, 4 times 1 is 4, 4 times -4 is -16, 36 minus 16 is 20. Okay, 20 is positive, so again, we have two real roots. But since 20 is not a perfect square, we have two real irrational roots. Okay? So the one scenario we did not see here is two complex roots. So remember, if your discriminant simplifies to a negative number, that means you have two complex imaginary roots. So I hope this helps you in determining the nature of the roots, and I will see you next time.